Hello everyone, this is Sabiuddin Ahmed Siddiqui. Now we are going to take a route on Applied Information and Communication Technology. The syllabus component code is 9713 GCE AS level. Before we proceed any further, I'm going to introduce myself. You can see the credentials. I have done Masters in Computer Science, Diploma in Computer Science, and I have some other combination of studies. And I have been associated with AICT Computer Education, where I'm teaching as a certified teacher for Java, Android, C#, VB.NET, SQL, ASP, and you can see the education management as well, where I am associated with the Beacon House school system, teaching ON A levels for computer science, and Edupedia World, where I am associated with computer applications, creating and developing Java videos and lectures, and with the City School ON A levels, and as you know that AICT Computer Education, where I am just teaching online and offline both categories, where I am teaching Java, Android, C#, VB.NET, SQL, and ASP. Apart from this thing, you can see the profile industry and corporate experience, where I am associated with networking, software development, online courses. I have published some online courses, and you can see the most important, that is research and development, where I have been associated with research and development for Android, Java, and some other computer science articles for ON A levels. So continuing with the ongoing topic, I have chosen Systems Lifecycle for AS, the introductory topic, that is Systems Lifecycle, and the subtopics are analysis, design, development and testing, implementation, documentation, evaluation. Now we will take a brief look for each component, so you can see the explanation and the understanding of the topic. Now first of all, we have the systems life cycle, where the first stage starts with the preliminary investigation. That means that you have to find the problem first, and then you have to chop down the problems, and then you have to investigate in each manner, such as for example interviewing, observing, and something like that, to get the actual status of the application being developed. Now before you proceed any further, you have a feasibility study, that is analysis. Now what you have to do is here, that means you have to find the feasibilities that in these conditions and circumstances the problem will be solved easily. When you switch over to the design statement, so make sure that you have all the feasibility studies done before moving to design phase. Now when you switch over to design, you have to take care of the input layouts, output layouts, and other site visits and something like that. So this is the design which is very important, where you will design everything right from the beginning, or you can see that you have to assume the system that you are designing the system for novice. And if you do not keep this idea in your mind, so I studied that thing, and normally the analysis phase wasted, and 80% of analysis are wasted. So make sure that you have investigated the problem correctly, then you have the correct feasibility, and then you have switched over to the design phase. Now when you switch over to the development and testing, you have lots of references for developing and testing, and such as for example development of modules, software development, and something like which is required by the client. So in that way you will start developing things on the basis of design. Now moving on to the implementation, where you implement, that means physically create the items and the information sets which are designed, and then you are going to physically implement with the help of some languages or software available. For example, any languages, high level languages or low level languages, if it is a combination of low and high level languages. So you will keep the status up to date with the design, and feasibility status. Now moving on to documentation. Normally we have two types of documentation, that is user documentation and technical documentation. Now these two documentation are very important. As far as the user is concerned, you have to design the whole screens layouts for the user to understand and explaining each object, how to use, how to install, how to perform functions, and how to you can say even simply even that how to do all the operations with of the same software. If you talk about the technical documentation, in technical documentation there are all the data dictionaries, there are all the tables, fields, variables, and the size types, and even you type the form size and form name and everything like that. So this is what the documentation is, where you already test, you will show the testing as well. For example, normal data testing, abnormal data testing, and extreme data testing. Now when you switch over to evaluation, so this phase is the phase where you evaluate your ongoing system according to the previous and future development aspects. For example, if you are currently using, let's suppose, the application on desktop PCs, now in the future you will be using the desktop application. Instead of desktop application, you will be using the online application for the same. So this is the basically evaluation, and what features will be included. Let's suppose you can access the web page from anywhere in the world. So this is the future evaluation. Now continuing with the next slide. Now feasibility study, as we know that feasibility means the circumstances which are favorable or the conditions which are favorable. Now basically we have to see at least 4 feasibility status. That means first of all you need to see that whether the software and the things you are going to develop is legal. If it is legal, then go ahead. If it is not legal, then you have to find the legal aspects for the development of that particular module or something like that. Then you have to see for the logically feasible. That means, for example, is this the description related to the topics or condition or the problem which is not in real world. Let's suppose the application is developed only for, let's suppose you are driving a car. So how to operate a car? Yes, it could be possible, but you have to create the pros and cons for that application which can directly control the vehicles. So logically means, for example, if you are trying to, that means it should be feasible enough. That means you are just going to, let's suppose you are present, yes, your presence should be there. But if you are making the decision that if you are not present and you are highlighting, and the program is highlighting you and you are not present, that means this is illogical. That means the logical error. And the thing is, logical means it should be logical. That means that can be worked on, that can be worked easily. And moving on to economical, that means it should be financially economical. That means if the client has invested $50,000, so the budget should not exceed the limit. You should be optimistic, not the pessimistic. If you become pessimistic, that means you exceed the limit of $50,000 to $60,000. Definitely the client will not come again and your analysis will go in vain. So economically, that means the financial conditions should be met smoothly. Then coming on to technical. Technical means basically whether it is technical or if there are any problems. Let's suppose how to, you can say, operate the system and something like that. And let's suppose if it is one entry and exit and something like that, yes, the system should not terminate itself. There should be a control and something like that, where if you are going to some module, the module should be controlled by some inner modules or something like that. So loops and something like that should be technically used. And the redundancy or exuberance of multiple loops or modules needs to be, you can say, apply in a way that it cannot be redundant. So it should be technically dealt. So there should be a technical dealing with the objects, modules and loops, so that the program can work smoothly. Otherwise, if you have used unnecessary technical technicalities such as using loops, modules, objects, and something like that. So even simple, if you will be wasting your time and your for software will not be good for the application. Now continuing to the next slide. Now what analysis itself teaches. Basically, if you take a look on analysis, now it does what? The analysis involves some or all of the following stages. You can see, first of all, fact finding. You can see there are 4 elements I have jotted down there, that is observations, questionnaire, interviews, site views, and surveys. As far as the observations are concerned, you basically in person go and evaluate the system by seeing with your naked eyes that what is happening in the organization or institution or the industry. Whatever you see, you record on the minutes book and then you bring it to the analyst, or being an analyst you keep it with you, and then you design a solution on the basis of those observations. Then if you are not certain about the observations done by yourself, you are going to design a questionnaire so that you can get the random answers from the users, that which kind of problems they are facing and which type of information they have. And for example, if by mistake you are unable to detect all the problems by your personal observation and involvement, so this is the questionnaire which provides you the comprehensive detail and information and the picture of the data movement. What does it provide you? Moving on to the interviews. Again, interviews should be taken to find out the information about what the CEO is going on and what they have planned to do something in future and what they are dealing with and what is their profit and something like that, and how to just what are the qualifications, something like that. And they should be of 2 types: structured questions and unstructured questions. So you have to plan it fast, because you cannot take more than 40 minutes or 45 minutes from the CEO or the organizer or the manager who has called you to develop a system. So make sure whenever you are conducting interviews, your time should be limited and all the questions should be structured, and if something like that you want to ask, it should be properly structured. Now apart from this thing, you have site views and surveys. Now site views and surveys means, for example, you have personally observed everything, the movement of data from one office to, let's suppose, your warehouse and something like that. So you have seen everything moving around. So this is basically site survey, so you can get the picture what to do and what not to do. Now moving on to the parts which are included in analysis, you can see the points you can keep in your mind as an analyst. Understanding the system, produce data flow diagrams. Now, I would like to just explain a bit about data flow diagrams. That is data flow diagrams that tell you the physical and logical movement of data. So identify the user requirement, identify the user requirements, and then interpret the user requirements, agree the objectives with the user. Yes, if you are capable, that we have discussed about the logical, illogical and technical and economical statuses. So you can see that everything is to be agreed. Yes, because you will be starting the work on the agreed statement. Then you have to collect data from the current system. Moving on to the next, that is system life cycle. What the system life cycle itself? As you can go through the description written above, a systems analysis team is often brought in to improve on an existing system. Frequently this involves moving from a paper-based filing system to one which is computerized. The following revision notes describe some of the key stages in a system analysis study. Many of the topics are covered elsewhere, such as how to choose hardware, validation techniques, testing, etc., which we have discussed somehow in the feasibility technicalities. Then move on to feasibility study. Basically this study is the study, or the you can say specification document, which is used to start, or this based on your system analysis. This involves writing a report to convince management of the merits of adopting the proposed new system. Some aspects of the study include terms of reference, objectives, boundaries, constraints. As far as the terms of reference means, on which terms you will be designing the system. Objectives means, for example, addition of records, deletion of records, maintenance of records, generating reports and something like that, or the buttons format, or the touch button formats, or the let's suppose it should be a pictorial ones, and pictures should be placed everywhere, and it should be the document which is only one entry, one exit point, so something like that which will be written in the objectives. Then coming on to the boundaries means, that means the system is limited to, so the system cannot work outside the boundaries. For example, if it is generating the reports, that's it, but it cannot send the email. For if you have designed it to just up till to generate the reports, that's it. To send the emails with the reports is out of the boundaries, because you have not set the conditions with the customer, so that is why it will keep the information but unable to send emails. Then constraints means one entry point, one exit points. All the constraints, let's suppose this is a logical constraint, if I get the money, if I not get the money, the module will be deleted, or the expiry date will be this, or the evaluation date will be this, or the new system will be up in these days, and so. So this is basically the feasibility study constraints, and something like the costing, budgeting, and vendor cost, hardware cost, installation cost, something like that, everything includes in here. Then you can see the description of the existing system, including any problems and the projected costs, criteria, that is essential requirements and desirable features of the proposed system, and what the solution you give to the customer is, basically including development plan and cost benefit analysis. Basically, what does cost benefit analysis include? Basically, it includes all the system costs, material cost, in terms of, let's suppose, buying hardware. Then you have a personnel cost, let's suppose how many operators or users are required to operate the system. So in all these ways, or all the solutions, you will suggest the exact feasibility, so that when it is approved, you will start working on it, on the system development. If the feasibility study is accepted, then the system analysis moves to the next stage, which is a full analysis of the system. That means detailed analysis. Now moving on to the next, fact finding. Now what is fact finding? Basically, now we are seeing and understanding that what is observation, what is questionnaires, what is interviewing, what is looking at existing paperwork. So this is all you know. That means observation means you know that what to do and how, what the matter and what matter should be found. Then questionnaires, you know that what the questionnaire should be regarding. Let's suppose if you want to collect the system information, you will design the question accordingly. Interviewing, if you want to get the profits and you can say the total turnover of the company, so you will design the interviewing structures according to the requirements you have set. Now if you are interviewing for this, that you want to enhance the system, so you will be interviewing the CEO or managers or supervisors to improve the weak areas and to improve the loopholes found in the system. Now looking at the existing paperwork, where that means site visits and surveys, something like that. So this is the all paperwork. This allows the analyst to see how paper files are kept, look at operating instructions and training manuals, check accounts, etc. This will give the analyst some idea of the scale of the problem, memory size requirements, type of input output devices needed, and so on. They will often gain information not obtained by any of the other methods described above. However, it can be a very time consuming exercise. So I think this will be kept in mind while doing the analysis. Now moving on to design phase, that is very important part. Now you can see, as we know that design basically includes the input layout designs and output layout designs, and which includes for the system analysis which has taken place, and the systems analyst has some idea of the scale of the problem and what needs to be done. Now what the job of the analyst is, that while doing analysis, he or she has to find the key parts of the recommended system, and on the basis of that they follow a list of tasks that are developed or that are jotted down, and then on the basis of that they start working on the list. We can take a look of some points which needs to be you can say keep in mind. That is, design the data capture forms or input forms. Let's suppose where the field should come, or if you're designing the input form or the layout form or the manual form, that is hard copy or the soft copy, so the screen should be designed accordingly. Let's suppose if you have ID or social security number or something like that, or so you can just keep it, let's suppose at the extreme left, so it should be printed or it should be hard copied accordingly according to the screen design. So this can be helpful to fill in the data. Design the screen layouts, design output forms and reports, produce system flowcharts and of pseudocode. Select if you are well aware of pseudocode, that means the writing methods in a language, and you create a you can say not real statement but according near to the real. So that is known as pseudocode. Select design and validation rules that need to be used. Select the most appropriate data verification methods such as validation, verification, and the data type which you want to accept, which you don't want to accept. Let's suppose in a number field there shouldn't be any field accepted except number, or if you are accepting input in a text field, so there should be only text, no numbers. Instead of if you are writing the address field, so that contains letters, special characters such as slash, dash and dots, so this can be in numbers, let's suppose house number, something like that. So select the most appropriate data verification methods or file structures. Table needed to be designed on agreed based. Let's suppose whatever you have designed should be agreed by the customer. Now the implementation phase. Now this is basically the final step which the analysts or the programmers collectively do this, and the system has been designed. It is then necessary to put together the hardware and software and introduce the new system. Basically in implementation you normally install the hardware and if necessary the new software, fully tested the system, and then new system once installed, train the staff to use the new computer system, and on the other hand you can see the transfer the paper file access across to the new system. Now this means, let's suppose we have different methods of converting the old system to new or to direct cut over. So now first of all, change over to the new system. Change over to the new system means, let's suppose you are changing the old system with the new system. Then there are some phases known as direct changeover. That means you do not consider the old system, you abruptly replace the old system with the new system irrespective of that which is matching or not. Let's suppose user are well trained or untrained. Let's suppose user are totally unaware of this thing, that when they are coming to the next day, so they will be seeing that the new system is installed and they are just making faces or something like that, that they are not aware of this thing, how to use the system and how the things are done. So direct changeover basically it makes lots of, you can say, mess up. So this is the direct changeover where you can totally, or you can just build the self-explanatory help, so that can, whenever you want to use it, the demo will be run automatically, and on the basis of that it can direct and explain the user. Now parallel running means you can keep the old system with the new system, and as the old system does, you practice the new system in the same fashion, so that all the data can be transferred to the new system easily or parallelly. Now pilot conversion means, that means a pilot, that means it will hold only once. It will not operate until the all things are done. Then phase conversion, you will implement first part, then second part, then third part. For example, if you are implementing the user registration or the employee registration, the next part will be account, the third part will be, let's suppose, HR. So you are implementing the things in a phases, or let's suppose the hardware phase is done, the software phase is done, the software required is done, and then hardware components which are required. So in each way you have different ways to phase things. So this is the implementation phase. Now the evaluation of the system. Once a system is up and running, it is necessary to do some evaluation. This is summarized, that how the system is evaluated. Now you have to compare the final, some points we are highlighting here. Compare final solution with the original requirements. Identify any limitations in the system. that I have discussed, that if you want to update in the future, so you can just identify that this was limited and now we are going to unlimit this thing. Identify any necessary improvements that need to be made. Evaluate the users responses to using the new system. Then compare test results from new system with results from the old system. Then surely compare performance of the new system with performance of the old system. Now definitely if you have the old system, so definitely if it is slow, or if the new system is faster, then definitely there will be a great change, and user will become happy once they learned about the use of new system. So I hope that this session will be fruitful, and I'm hopeful that this slide will explain and clear your concept about systems life cycle. So thanks for watching.